Test 1, 2. Where's my sound? Where's my sound? Hello, can you guys hear me? I think maybe you can now. Yeah, sound is on. Okay, can you guys hear me? That's the question. I'll find out in a second, won't I? Okay, I am here, and you probably have an echo. And I'm on the sound speaker now. Okay. There's the Comet. That's Comet NEOWISE. All right. Oh, good. Thanks, Neutrino. Nice to hear from you guys. I'm trying to figure out how best to do this. So let me just check something out here. Okay, well, apparently I'm not gonna be able to hear my own music, which is fine. I'll just keep it low. But we do have Comet. And I'm really pleased that we have the Comet. I can't believe it. I did not expect that I was going to be able to see it. It wasn't obvious. And I'm still have to get... I was just finishing getting everything set up. And I said I better just test to see if I can even see the Comet. And wow, there it was. So fantastic. And I have to see if we can grab Daryl if he wants to join. Let's find out. Gosh, look at that. Okay, first things first. Let me go back to the screen here, and we have our Comet right there. And what I'm going to do is move the telescope down a little bit. As it gets darker, we'll be able to do longer exposures to test this, to get this to work. And that's kind of a good thing. So we'll do that here. Let me just... No. Don't you even tell me that I have to restart my computer out there. No way. I'm not restarting the computer. Just a second. I'm getting rid of this stupid crap. Okay, we're going to just go like that. Be done. All right. Wow. And you can see the green of the Comet. That green is actually the cyanogen, which is cyanide, basically. And you can see the sky is a little bit bright, as you can see here in the dome. We got a little bright sky. We want to get rid of that to take a longer exposure, but I'm going to try it anyway. Let me go up to 8,000. Let's see. Let's try and blast a 4-second exposure here. Let's see what we get. Here we go. I want to start picking out a tail. That's what I want to do. And let's see what we got. Wow, look at that, huh? It's a beautiful Comet. Okay, now... Yeah. Yeah, this is a stunning Comet. It really is pretty. It's about a magnitude 3 right now. So it's looking pretty bright, you know. Okay. Wow, look at that. Just a second. Yeah, so once again, this is Mark D'Antonio. This is SkyTour LiveStream for July 17th, 2020. The comet is visible. Comet NEOWISE. It looks pretty beautiful in the sky. And as it gets a little bit darker, it also gets a little lower to the horizon. So I'm trying to see if we can get any kind of a view of the tail. So what I'm going to do is I'm going to go up to 10 seconds at 1000, and let's see if we can start picking out the tail. Okay, so here's what it looks like in a photo. You can see the coma here. It's really extensive. It could be, several Earth diameters in size. Yeah, there we go. I mean, you can't really see the tail yet, but it's pretty. We need. I see you got a little edge of the dome here too. But we don't have a choice right now. It's really nice though. Wow. I want to just get more. I want to just take longer exposures. Just want to take longer exposures here. Okay, Daryl nor Amanda has responded at this point. And that's okay. I will just wait and see, Let me get down here. I'm glad sound is good for you guys. I'm just working this out here. Okay. Not sure how long the comet's going to be up. We also have some clouds on the horizon. Now one thing I could try, which I will do, is I'm going to get us back to our view here. And what I'll do is I'm going to go and look at the... right now we're in the wider narrowband filter. This is the ultra narrowband filter, and now I'm going to be doing the visible light. Okay, this is the visible light shot. We'll do 10 seconds at visible light to see if that shows us any more. Yes, Philip Blair, it's still light here. We can see the comet. The purple is actually a reddish interference with some of the red from the dome. I have to go out and move the dome in order to get that fixed. Just move the dome a little. But here's the comet right here. It's really, really nice. And you can see the glow around the center. That's probably multiple Earths in diameter, maybe 7 to 8 Earths in diameter. We're supposed to be able to see a tail, but can't see it yet. But it looks really pretty. It looks really pretty so far. And this is the first night that we're actually getting to see the comet from SkyTour LiveStream East. And SkyTour LiveStream West I'd like to be able to tell you that it would be coming online later tonight, but it's not. We still have to build that. Sean Farva, you're asking a question about Jupiter's debris field. I'm not sure. I have not seen that, and I will have to look for it. Hello, Daisy and Zoe. And Dew is here. Terry Groff is here. Good to see you guys. Neutrino is here early. So is Cypher 2. Battle Pyro, welcome to SkyTour LiveStream. Ankit Anand, how you doing? Gaia Civilis. Good to see you. Angela Smith. Really nice to have you guys here. For those who have never been here before, let me just give you a quick tour of the screen and how things work in the SkyTour. Okay, so first things first. Okay, on the left side over here, we have the telescope control cluster. This controls the telescope, these north, south, east, and west. Whoa, there goes a plane right in front of the comet. Did you guys see that? It's all being recorded too. Fantastic. Then this is the telescope controls and computer access, and this is the filter on the telescope. This is me. Hello, yours truly. And this over here, which you don't see yet, is the camera for the dome, and it's right there. Okay, you can see it right there. And then on the right side of the screen, all right, on the right, come on here, on the right side of the screen, this over here is the camera control system over here, followed by the observatory view. So, and in the center is the live view. So we control the telescope here, so I can move the telescope, as you'll see. There goes, move the comet up a little bit, move the comet down a little bit. Don't know how high above the horizon it is right now. I can figure it out based on the this number right over here. The altitude right here. It says it's about 17 degrees. The telescope's pointing 17 degrees above the horizon right now. So we're looking at only 17 degrees above, and that's just above my trees that are at that end of the property. And to see that, we have our other screen that we bring up. This is our view. This is actually our actual view. There is the house. There is the southwestern horizon, the southern horizon. Okay, and then this is the actual observatory dome. All right, and this is the actual landscape here. So we actually have an accurate rendering of where we are. So you can see where the scope is right there. And if we look online here, it tells us that we're about, this is 20 degrees here, so this is 17 degrees. So it's going to go down this way. So we have a little more time here. And I think that's pretty cool. That's really nice. It'll give us the time we need to do some more views. Hopefully it'll get a little darker. Yay. We are in visible light. So I'm going to go up to 15 seconds to see if I can pull out anything in the visible light here. So here we go. I'm taking that picture now. And by the way, I can move all around the screen and point to what we're looking at and enjoy our view and show you everything directly. And that's kind of what I like to do as well. All right. Hey, David Schmidt. How are you? Yeah, a little more red. That red is the dome interfering. I am going to have to go out and move the dome so we can actually... Oh, look at that, huh? That's beautiful, though. Yeah. Okay, you know what, guys? I know you can hear music, which is good. What I'm going to do is I'm going to go out and move the dome. I will be right back. I want to get rid of the red. All right? Be right back. Okay, dome has been moved. And the next shot won't have any of the garbage in it. Oh, look at that. Look at how well that looks now. Holy cow, this might be the one. We can see the tail now. Look at that. Wow. That's all it took. Oh, I'm so excited. Here we go. Live Comet NEOWISE right there. Watch how beautiful this looks when we come back. Wow. Look at that. Oh, wow. Amazing. Got a little issue with the guiding. I'm going to go take care of that. But there's the tail of the comet. And we're going to get this looking really pretty in just a minute. Man, wow, that looks beautiful, guys. Okay, let's do this. All right, first things first. Adjust my parameters here. Go into the telescope controls and go down 1, 2 to that. Enter the right ascension guidance control. Set it to 5. Enter. Go down one more to the declination guidance control. Set that to 0, 1. And enter. And then back out. Okay, so we're out of the computer now. And now what we're going to do is we're going to lower the telescope. Raise the telescope slightly. All right. And we also have to focus. So let me just get the focus screen up. That's our focus screen. All right. There's a very high-tech way to focus. So let me do that too. Right there is the center of the focus. So we're gonna literally gonna put a little dry erase marker dot on the screen. And now all I have to do is move any object over to that location to focus. So let me do that. So yeah, let's look at the comet. Wow. Wow, I'm impressed. This is the comet of the century, let me tell you. All right, then we're gonna go and move it east. Bring the comet in, and if you want to see it like all really up close, and this is the focusing screen. There's the center of the comet we're looking at right now. That motion you're seeing, that jiggling and motion on the screen, that's actually just the moment-to-moment sensor of the camera. That's not actually showing you anything specifically. So let me move this out for a second. I'll bring it right back. I just have to bring in a star to focus, and that star is right here. Okay, we had 2 stars to focus on, so now I can focus. As you can see, it's going out of focus. When it goes out of focus, they look like little donuts, and they look like pretty nice dots when they go into focus. Okay, so now I can bring it back. There's your comet, guys. Hey, I hope you like this. This is pretty cool. I just saw a satellite go through. I don't know if you saw that up here. And let's see. Wow. Hey, Daryl's here. Daryl, you want to come in? If you want to come in, let me know, because I actually was looking to have you come in. Maybe you... Oh, yeah, you said give you a couple minutes. All right, that was a while ago, so that's a couple minutes. I'm going to try and call you. Sorry about the noise if you hear it. God, that's loud. You don't hear it, I do. Okay, he wasn't ready yet. Let me bring up the music again, because the music is nice in the background. All right. Okay, here we go. Okay, so now let's get some photos here of NEOWISE now that we're all focused up. We're gonna bring us over here and then bring us down again. I want to try and get the full extent of the tail. The tail is really long, so this may not even cover it all, but we're gonna try. All right, here we go. This will be a 15-second shot focused with visible light, not anything else, no filters. Here we go. On its way. On its way. All right. Man, I'm just... this is really incredible. Oh, look at that. Wow. Look at that. That is just... oh, that is utterly spectacular, guys. Look at that. There it is, Comet NEOWISE. Wow, this is a beautiful shot. This is a wonderful shot of NEOWISE. Daryl, I know you're out there in the chat. And when you're ready to come on, that's great. So let me know. This is just so cool. And as I was right, the comet tail goes the entire length of the view, which makes sense because the entire length of the view is just under a degree. Just under half a degree, and the comet tail goes multiple degrees. Is this not pretty though? Look at that. So here's what we're looking at. Okay, over here in the core of the comet, right here. Okay, in this head of the comet right here, we're looking at this green. This green area is actually called the coma. The coma is multiple Earth diameters in size. And when you look at the green, that green is from one particular compound that stands out amongst the other compounds, and that is cyanogen. Cyanogen is a carbon atom and a nitrogen atom together, and that cyanogen is a compound, of course, that is toxic to humans. All right. However, in the 1800s, there was a Camille Flammarion was the Carl Sagan of his day, and he suggested when the 1910 apparition of Halley's Comet came around that because of cyanogen in these comets, if the Earth went through the cometary tail and there was cyanogen in the tail, well, guess what? We would all be bathed in cyanogen and we would die. He was speculating. He didn't really say it was going to happen. It got taken the wrong way, and Flammarion had egg in his face for quite a long time. In fact, that became the one thing that he wished he never said. But look at it. Isn't this beautiful? I mean, this is a gorgeous comet. And there's that tail. I'm going to try and see if we can refine the tail just a little bit. I'm going to bring this over a little bit. Bring it up a little. Okay, so we're bringing it up just a little bit so it's in the view. And now what I'm going to do is I'm going to go, because it's darker now, I'm going to go for 25 seconds, and we'll do it at 1250 ISO. So we're going up by 2 stops, so it's going to be brighter. All right, this should be cool. Dude, that's a good thing. That's a good thing. You're going to plan on living forever? Good, me too. How's that? So with your eye, the comet might not even appear fuzzy like this. It's really, its magnitude is fainter than it was a few days ago. And oof, wow. You know, it almost looks like that could be fake, you know, but it's not. And again, the beautiful green of cyanogen and that gorgeous tail sticking out there, just beautiful. We're actually, I'm seeing that this particular exposure needs to be done again. Oh well, I'll have to do it again. Heaven forbid. And then this one here is probably better, but you see the stars are round here. Yeah, D17. That's right, D17 Tom. More hours. Yeah. This is really beautiful. Yeah, we'll watch this, and we'll watch the comet until it gets too low. There are thunderstorms out there, and when I went outside, I noticed there was some thunder heading out in our direction. But I don't care. I'm going to keep going until we can go no longer. Right? So, really, really cool. Let me go back here and bring the comet up. I'm going to try something else. I'm going to actually drop us down to a very low ISO, low speed. Okay, and take this is 50 ISO, it's the lowest the camera can go. And I'm going to drop this down to 20 seconds. No, 15 seconds. I want to see if we can see detail now in the coma. And it's a little bit low, so I'm going to have to bring it up. But I will. Okay, so 20 seconds. And kaboom. Now let's go take a look at this. Let's spin it and zoom it. Here it is. Interesting. Okay, we actually can see, you look for the colors. Okay, right now you can actually see that cyanogen is actually pretty green and forms an overall green color here. But you also have another color in here, and that color could be reddened by our atmosphere, but it may very well be that's cometary dust that has been expelled off of the nucleus and is in the process of being driven behind by other material. There's other things going on too. That the tail you saw going up there, that's the dust tail. So when we look at this image, for instance, okay, this is the dust tail, right? And the ion tail is going to be not really visible in this shot yet. There's two tails on a comet. One is caused by the solar wind interacting with other particles in the cometary coma here, and that is always pointing away from the sun. So that tail should be going somewhere toward the right side here. All right, and we don't really see. We see kind of an elongated nucleus. Maybe it's sort of going into the picture a bit. And then the dust tail is just the stuff that's getting left behind and could form a meteor shower next time we go through it potentially. But this particular comet, when we look at the way it's traveling, we may not ever pass through its tail. That remains to be seen. So that's pretty cool. Okay, hold on. I'm gonna call Daryl now. And Daryl is with us. Hey there, Daryl.
Hello.
How's it going?
Oh, it goes. Sorry, you caught me just about to have dinner when I got your message.
Well, that's okay. I mean, look at what's on the screen. This is the
I
comet.
am.
We are having a ball now. Yeah.
Good.
I'm glad you could join us. I'm gonna keep up and I gotta put the comet all the way down the bottom of the screen in order to in order to get any any vision of the tail.
Very good. Could you share screen with me, please?
Oh, okay. Of course. Let me do that.
Hello, everybody.
Okay, sharing screen and sound.
Very good. Thank you.
Sure. No problem. Yes, indeed.
I'm glad you got to catch it. I know you didn't have to wait till the 20th either, like you were saying the other day.
Yeah, I was thinking I was gonna, but it looks like we're okay. I'm gonna bring it up into the view a little more, just so it's more centered, even though the tail goes way, way many degrees beyond the field here.
Yeah.
So this is our typical view that we have here, guys. And when we, as I said to the newcomers, you can see the telescope control section is this guy over here. All right. This controls the telescope. This gives me access to the telescope computer. This gives me access to the focusing. And this is the filter wheel. We currently have it on filter wheel 5, which is a just straight through, so we can see the true colors, natural light color. Down here, this is me. Hiya. And over here is the view inside the dome. And then we have the camera control cluster over here. So then we have the live view right in the middle. So this is a live view you're looking at. And if we were to zoom in on that, which I used to do focusing from time to time, you can see the comet core right here. That's actually, it looks like it's boiling and fulminating, but it's actually not. That's the camera sensor doing that. I'd love to say that was the comet doing that. Hello, Kimmy. How are you? Carolina Sky, how are you? Good to see you here as well. And now I'm in Carol Carl. Hello. So this is beautiful. So now let's just take another shot And I think I actually got the setup right, but I'm going to do it anyway. I'm going to go and do this again. I want to get my right ascension done right here. I think I did before, but I'm going to do it again. Alright, and I'm going to go down one more. And go into this guy and set him, make sure that he is set correctly. Alright, so now the computer has been instructed to guide better, I hope. Okay, let's do, let's go way up, as high as we can go at the moment. Let's say 3,200 and 25 seconds. So let's see what we get. I want to be able to get it refined. Now, as time goes on, like tomorrow, if it's clear, it'll even be higher in the sky. The night after, even higher in the sky. We'll have more time with it. So the telescope is performing really quite well right now. And let me change over to the night vision system inside the telescope. Okay.
I was looking at the Sky Live page for the Comet.
Yeah, I was too.
Set for my location, and on the 20th, I think at 9 p.m. it's going to be 30 degrees above my horizon.
Wow, you're going to be able to see it just fine.
I don't know. I've said before, looking northwest, I'm looking through all the sky glow all along the Front Range of Colorado.
Yeah, that's true.
From Colorado Springs up through Denver, and it's bad anymore.
Yeah, I know.
But I'm going to give it a try.
Yeah, unfortunate. I just want to welcome everybody. There's over 75 of you watching. I think that, go ahead and post something in the chat if you'd like to, be recognized. Be happy to let you know what I see out there. This is just beautiful. It almost looks like a fake picture, but look at the dust tail here. The dust tail is distinctly reddish, okay? And that's not the telescope doing that, because we're looking with just normal light. That's actually the dust as illuminated by the sun and reflecting the sun's light. But we are seeing it through some atmosphere, so it's going to look reddened anyway. Just like we see a red sunset, at a long angle on the horizon, okay, like that, through much light in the horizon. The Earth curves, so it goes around the curve, and we're actually looking through all that atmosphere. So the light's going to be a little bit red, all right? But again, we do see the core of the comet here, which is that characteristic green color, which is the cyanogen color. And cyanogen is really, it's very low density, by the way, as is all of this here. Hello there, Pilar, how are you? And Esawan, how are you? And Dr. Fox, welcome. Yeah, so let's go back here and get some more comet going. I'm actually gonna try something crazy. I'm gonna go do 30 seconds. No, I'm gonna do 1 minute, and the comet will actually move during that time. But I'm gonna do 1 minute at 2,000 just to test the guiding. Meanwhile, we'll come back if that photo is underway. And now we have our comet here. Boy, that's really pretty. I'm telling you, this is the size.
It is.
Yeah, it is definitely the comet of the century. It did far better than, it did far better than the other comet that was supposed to be beautiful.
Yeah, Swan and Atlas, were they?
Yeah, that's right. Yep.
You talk about the dust tail being the color of sunlight. I remember back when Comet Hale-Bopp came in '97.
Yep.
I drove up to the top of a mountain pass here in Colorado to get some altitude and, a clear view.
Yeah.
And it was just spectacular over in the west or west-northwest after sunset. And had a big, broad dust tail, and then you could clearly see the blue ion tail.
Yeah.
Plus a bonus that night, because it was in springtime, I was taking wide-angle photographs of it, piggyback on the telescope.
Yeah.
And the zodiacal light was coming up in the west to the southwest.
That's
and
beautiful.
it just made for a gorgeous view. And
Wow.
both the zodiacal light and the dust tail were exactly the color of sunlight.
Wow. That's really
It
pretty.
was just spectacular.
I love it. Okay, we're still exposing here. Just to let you know, I saw a question in chat. This comet right now is 6 light minutes away, meaning it's about 3/4 of a astronomical unit, 3/4 of the distance from the Earth to the Sun away from us right now. And it takes about six minutes for the light to get to us from there. And Dew is asking a question about what causes the tail to form. You know what? That's a loaded question, Dew, because there are 2 tails on a comet, and let me talk about that for you. Number one, and this other exposure is going to overlay this when it's done. Okay, if we look here, okay, this is what's called the coma. This is an active region that can be many Earth diameters in size, and it's a direct result of the material on the nucleus of the comet, which is tiny. You wouldn't even be able to see it in this photo. Very tiny, and it would actually be boiling off this stuff because of the sun's energy striking the surface, and so that goes up into the area around the comet in space. But at the same time, you got to remember that the comet has accumulated lots and lots of dust and particles over the billions of years that it's been out there. So that being the case, we're also looking at dust that's being blown up off the comet too by all this reaction. Because when the sunlight affects the comet nucleus, okay, we'll see. Okay, see, that's a little too long for the amount of light that's still out there. So we'll come back to this guy. When you look at the comet's tail, that dust has been pushed back, okay, in part, but with the solar wind and the interactions, but mostly because it's pushed off the comet and just hangs there in space, but the comet is still orbiting and keeps going, so it's leaving behind a trail of debris. That's what we're seeing here. That's what all this is a debris left behind. This is the path of the comet right here. Right? It's going this way. Okay? It's going down toward the bottom. You know, in this particular case, because we're seeing the dust tail, and it's actually heading away from us right now. So we also expect to see the ion tail right about like this, I think, at this point. And the ion tail is what happens is that that nucleus of the comet. Okay, when the solar wind strikes it, it's electrically charging particles on the surface of the nucleus, and when those particles come up, they can be ionized and pushed backwards as a plasma because of the high power solar wind that's hitting it. And that plasma is a characteristic blue color. And we would see a blue tail as well as this dust tail. Right now, we don't see that. So the ion tail is probably lost in the glow here. So that's when I took images earlier. I was trying to capture the ion tail. So hopefully that answers your question. I want to say hi to Smoke. I want to say hi to Dot4, or EOT4, and Bob Harless. Welcome. And Genghis, hey man, how you doing? Do you have something you want to say, Daryl?
Just to add on to what you were saying, the actual cometary body itself is buried in the center of the nucleus.
Yeah.
And it is about 5 kilometers across, or about 3 miles.
Mm-hmm.
So, as you said, I mean, it's so small down in the nucleus you can't even see it.
That's right. We never see it from here, 3/4 of an astronomical unit away.
Yep.
But you know what? 25 seconds at 2,000 now. I think what's interesting is when we look at the comet over the course of several nights, hey Marco, I think we might find that the comet tail may have some distinctive features to it. We might be able to catch the ion tail. The one thing about the ion tail is going directly away from the sun at all times. Okay? So wherever the comet's going, it could literally be traveling into its own ion tail. Look at this comet, Daryl.
Yeah.
This is just beautiful.
It is.
Wow. Yeah. All right, but the dust tail is just debris left behind as the comet's passing through space. the ion tail will be always pointing away from the sun. Now the sun is kind of down there right now, so the ion tail should be pointing up here. And I don't think we have any hints of the ion tail yet, do we?
I don't see it in your image.
I see the green cyanogen halo around the coma, and then the dust tail left behind. This is really beautiful.
Mark, do you have any room left on top of your telescope to let a camera ride piggyback to get wide field shots?
Yeah, actually, I was trying to work that out today. I was out there trying to figure out a way to get another camera up there, piggyback, which I have had, and I already have a mount for it, but there's a guide system up there. And that guide system is something that is taking precedence. I got to leave the guide system up there.
Right.
Yeah.
That's what I was thinking.
Yeah, but
you mentioned the ion tail. It is showing up beautifully in long exposure, wide field, like piggyback images, and they're seeing discontinuities and kinks and all sorts of stuff in it from, I guess, variations in the solar wind.
yeah, and but are those? Well, we should be able to see the ion tail. If it's visible to someone else, it should be visible to us. Unless they're taking it from spaceborne platforms, I've seen some of those.
No, these were earthbound shots. They're saying the ion tail is like 20 degrees long or more. You'd need a wide field for that.
Well,
I don't know how much you would get with the close-up on the nucleus like we have here.
Well, we should be able to see part of it, though.
I would tend to agree with you.
All right, well, here's what I'm going to do. Let's do this. We're going to drop this down a little more.
Think a filter might help?
That's what I'm going to think about right now. Yep. I'm going to drop this down. That's too far. Actually, it's not. Here's what I'm going to do. We're going to do this, and we're going to go to the narrow wide field. And let's do, we're going to do a shot of the comet. You can see it right down here. We're going to do a shot of the comet with 25 seconds at 2000. These filters are actually tuned. Let me do 30 seconds. This filter should be tuned, and 2500. This filter should be tuned to catching the blue, because we are looking for what's called oxygen 3, which is not what we see in the ion tail. But I think we can actually still see that blue color. Depends. We'll see some of it. If it's there, we'll catch it. And the filter will probably do it. I haven't even taken a filtered shot yet of the comet. So this is the first one. You know?
To answer EOT4's question, million miles long, absolutely.
Yeah, that's right. Yeah, ooh, look at that. The comet, the comet coma here, this part here, could be just about, I'd say 6 to 8, maybe more Earth diameters in size. But this can go several astronomical units, over time. It could be really, really huge. It could be, hundreds of millions of miles over time. But again, I guess you could say that since the tail remains in orbit slowly, that the tail is even bigger. The tail could be billions of miles in size if you go all the way out to the extents. But I'm not sure if that's really a good analogy. Well, I'm seeing, this is actually a really pretty shot.
It is.
It's a pretty shot. The focus is not on right because I'm doing it through the filter, so I'm going to have to refocus. But I'll do that really quickly. I'm getting more comet than I expected tonight, to be honest with you. When I went out there to look for the comet, I put the coordinates into the telescope, and I just went over to the comet and said, okay, let's see if we can see the comet. Probably not going to see it for a few more days. And then I was like, whoa, that was wrong. We saw the comet right away. Holy cow. And it was just so beautiful that I rushed in here to get everything going. And that was just, Just amazing, you know. Okay, let's do this. Let's go here. There's my star for focus. Let me get rid of the blue ramp thing. So I've got my focus square up, and I'm going to go over to my focus here. And let's go focus. Let's go focus. Okay, we're out of focus. Now we'll come back in. You can kind of tell when the star is in focus because it's, you know, and that turbulence you see on it, the turbulence you see in here, that's all due to the current state of the atmosphere down this low in the sky. Okay, so let's bring the comet back. Let's go back, not forward. There we go. All right, and now let's do this again. But let's actually go up to, I'm going to go 4,000 for 30 seconds. What do you say? And I'll bring it down and see if we can see any more. I'll bring it tastefully down so it's not really near the total bottom, but close. Okay, a little pop-up. There we go. Okay. All right, this will be 30 seconds. Over here, as you can see, 30 seconds at 4,000 ISO. So that's pretty good. Let's see what we get.
Hyper DJ, to answer your question while Mark's exposing, Mars is in the morning sky right now. It's not visible at the moment. Jupiter and Saturn should be visible from Mark's location, but I don't know if he's going to have time to look at it. He said there are some thunderstorms in his area.
Yeah, I was outside and I suddenly, my house got illuminated by lightning. I was like, hello. So I was like, that's not good.
It's cloudy here yet again. I haven't gotten a look at it yet.
Yeah. Wow. Okay, so let me see if this gives us any hint. Yeah, nothing here yet that I can see. Yeah. It's something though. I mean, this is definitely a groundbreaking comet, isn't it? Isn't that pretty, guys? That is just beautiful.
It is.
Wow. Hello, Jack Marzi. Welcome. Yeah, this is something else, you know. Oh, and Tara's here. Hello, Tara. Tara's got some wonderful ideas for SkyTour LiveStream West. She and Marianne are two of the people that are helping, you know, with that project to help bring it to fruition. And I'm really, really looking forward to going out. I'm supposed to be out there already. This is Telescope 1, and we're going to have Telescope 2 out in the Sonoran Desert in Arizona. And it's going to be under a very dark sky. So we're going to be really being able to see some beautiful, beautiful objects. I think you saw the other day, if you saw my post, I did a post on Facebook which showed the nebula that we did. You saw the nebula, right, Daryl?
I did, yeah. You shared that.
Yeah.
Beautiful picture.
That was just beautiful. It was a nice exposure. I did 7 exposures of the Lagoon Nebula, and these 7 exposures I stacked, and only 7, and it ended up being just beautiful. Really, really came out beautiful. And you know, since you're saying, well, you may be asking how beautiful. Well, I don't know. I'll have to show you for those that haven't seen it. But I'll get to that here in a sec. I just think that it's absolutely the most stunning nebula in the sky right now for these types of things. If you want to look at other types of nebulae, well, then you can, and they're beautiful. But let's see here. Let me see if I can jump over. Is it going to be under here? Yeah. Yeah, this is the Lagoon Nebula that we recorded the other night. Okay, look at that. Isn't that beautiful? That is just a stunning, stunning image. And this is because We did 3 minutes on this in the sky. We did a 3-minute exposure, and I stacked them. But enough of that. We've seen that. Let's now go back here and check out our comet. Let's get to the comet, man. We gotta use up all the time we can here because the comet will be entering trees at some point, if it hasn't already. Let's do another exposure. Let's go to 8,000 and drop it down to 25 seconds. So we go up several stops, or 20 seconds. We go up several stops and come down on the exposure time a little bit. Okay. Oh, look, an artifact. That's not real. That's actually a camera glitch, that little red thing. Yeah. All right, so here we go. So this is, again, now we're using the wider narrowband filter. Okay. I don't know. I'm counting tonight as a wonderful success. This is just a successful night. You know? Look at that gorgeous comet. Wow.
I see stars in the tail. Are those real or are those artifacts?
No, there's a couple of stars that are in the tail, but you can see noise. And let's just go in and look. Okay, this red stuff is all noise. Okay, that's really there. That star is really there. Okay, that star is really there, and there's another one that was making itself evident in here. But as with all objects of this nature, they move in the sky, and we can see the movement over time. You know, so I think that's what's happening for that. Okay, I'm also noticing we got a strange little haze over here. It might be that there might be a cloud down there. So as many of you will notice, there's times when I'm going to, come back to our view here and grab, for instance, the all sky camera, which we may need. Okay, so there's the all sky. Let's bring that up. Camera's been found, of course, and we're going to go in continuous mode. We're going to do a 35-second exposure, and we're going to auto save all the images. I want to see if I can see the comet in this view as well, and then we'll say take photos, and then we can process them. Meanwhile, while it's taking photos, let's go back to the comet, which you may not see, but it's actually just out of shot down here. I'm doing that because I want to grab the tail as best I can. So I'm going to go up to now 12,800 ISO sensitivity and take a photo for 25 seconds. Carol, if you're talking about the two bright spots, if you're talking about, let's see if they're not visible to you actually right now. Okay, I'm not sure which ones. Hey James Dugan, how you doing? Okay, now that's interesting. We're seeing some kind of we're seeing a little bit of detail in the dusk tail here. See that? I don't know if you can see that. See how there's some rippling in the dust tail?
Yes.
Yeah. That's really cool. And I'm also seeing an additional thing here. I have to look. But we're doing good for tonight, let me tell you. This is really good. Jeez, this is beautiful. Wow. I was hoping we'd get some Comet NEOWISE action, and we finally got it, Daryl. Finally got it.
Sure did.
Yep. All right, so let's go back and let's try. I'll drop this down. We'll get some pretty shots. So let's go to see 6400 for 25 seconds. Let's try that. The comet again.
Blasphemous. It's in the northwest sky, presently under Ursa Major, the Big Dipper, and the Big Bear.
Oh, actually, I can show them directly while we're waiting, because here in our planetarium program, we can see this is Ursa Major, or the Big Bear, as you can see here. Okay, there's the Big Bear. There's the Dipper right here with the bowl of the Big Dipper. And the telescope is literally looking right there in that little notch between the trees. So that's where it is right now. And on subsequent nights, it'll be a little bit higher in the sky, kind of moving in this sort of direction. So we'll have more time with it over the next few days. I'm just so happy we got it today. This is really wonderful to get the time we did today.
You're going to lose it pretty quick.
Oh, I know. We are.
But you'll still be able to catch the tail for a while.
That's right, and that's exactly what I'm going to do. I'm going to hang out for the tail. We can actually ride up the tail now, if we wanted to. All right, so let's see what we got. Here is the one that was 25 seconds. All right, and we'll see another one. You might wonder why the telescope, I'm flopping it like that. That's just because of the fact that the telescope is on its side. So the image in the camera tends to flop, just like the iPhone auto rotates your image. Well, the camera's doing that too. I'm trying to stop that. I don't want to do that. Okay. And here are the bright stars, I think, that Carol was talking about early. Oh, hey, Cindy Murphy. I am sorry. And Tony the Night Owl. Nice to see you guys. I didn't say hi to you. My apologies. And Raztaz, how you doing?
Do you think those two stars are the front foot or front feet of Ursa Major?
Let's go see. Let's go grab our... yeah, I don't know.
Yeah, probably not. A little too far away.
Yeah.
Okay,
that's these
right
two
there.
stars right there.
Yeah.
And for people on know, we have a little... this is our field of view, essentially. It's a little smaller than this. And those are the two stars that Carol was seeing. And what are they? Well, let's see if they know them. Yeah, this is Hipparchus Star Catalog star 42773, or the Smithsonian Astrophysical Observatory Catalog 42504, or the Henry Draper Catalog HD 73933. I hope you like that. It's a 7.8 magnitude star, by the way, which means that its magnitude is fainter than the comet. I think the comet magnitude was around 3, but I saw 1.7 somewhere. It's not 1.7, because I think that might be the combined magnitude. But you can't go outside and just see this thing in the sky at this point, like this. You have to use binoculars or something to see a fuzzy spot. I don't know if you've seen it yet, Daryl.
No, I haven't.
Okay.
Weather hasn't been quite... summer monsoon is happening here. It clouds up every afternoon.
Okay.
Been raining, and it'll clear up sometime overnight.
Okay. All right, well, we'll do one more shot like this, and then I suspect it's in the trees right now. We're actually getting into the trees here. See that? Those are the trees. But... I took the time to align this. This is good, so we know where it's going to be, And we'll see now. And what we can do is we can actually take photographs up here, because that's where the tail is going to be. So let's go check it out. Oh, that's pretty interesting. Yeah, we'll zoom in on this a little noisy, but you can see some of the... you can see some really interesting filamentary type structure here. You see that?
Yes. Do you think that's real or artifacts?
Nah, I don't know. I mean, I have to look. But see, the general gradations here, those are going to be real.
Yeah.
But the red dots, those are noise, which I eliminate. I have algorithms to get rid of all that stuff. Hey there, Delta FX. How you doing? Yeah, that's beautiful. Okay, so next step is now we're going to start riding up the tail to check out the tail. So that's the nice thing about comets, because even after the comet is gone, you can just start looking at the tail. So let's go now and start looking for some more data. So let's go to 8,000 first and check it out. All right, and drop it 1. All right, and we'll do 25 seconds at 8,000, and the tail is going to be visible, and the head of the comet is going to be off the image because the head of the comet is now in the trees, but the tail's up here now. And we can actually ride up to find the whole extent of the tail too, which is kind of cool. So tell me, you guys like this? You think it's pretty cool?
I think it's cool.
Well, you don't count. I know you think it's cool. Yeah, no, it's really beautiful. Okay, that image is great, but I want to get rid of some of the noise. So I'm going to drop this down to 3200. And let's try doing a minute at 3200 and see what we get. Here we go. Okay. So in this image, the comet now is down out of the picture down below here. All right. And so with it being down here now, okay, we got to down there. Okay. Now we're going to look at the structure of the tail here and see more, hopefully going up. Because we know there's more of this tail showing up here. The tail goes all the way up out of the view here. And it's bright near the comet, and the brightness trails off as it gets farther away. And we don't want to be caught in that. We want to actually see the whole extent of the tail. So that's why the minute shot. It's going to look a little different from what you see here. It'll be less noisy and a brighter image. All right. Thank you, Carol. That's very kind. All right. So I wish that I had the spectrometer set up, which I don't have set up out there at this point, because I would love to actually be doing a spectrum of the comet's nucleus, and you'll see all the lines, and we could identify everything in the comet. You know, it's pretty cool. Hey there, Karen Belmont.
Would that work for an extended object like the tail?
Yeah, it's a slit spectrograph, so I can actually just take a small section. I could actually look at the tail, and as long as I can take an exposure that fills the slit, I'm all set. Yeah, this is a really, really good thing, you know. I think I'm still exposing here. Yes, I am. All right, we go back to this, and you'll see it. You'll see less noise and brighter tail up here when it finally comes in. So I think that wait a minute. I wonder if I left it on 3 minutes from the other night. I better check that, huh?
Probably.
I gotta check that. I did. All right, I left it on 3 minutes. That's the problem. That's why the other one was so bright. Okay, we're gonna set it to 1 minute. Okay, now the next, I can just say stop the photo and see what we get. Yeah, look. Wow. And it's gonna look at that. You look at. You can actually see this. There's some really cool structure in there. Wow, that's really pretty. All right, now I'll do 1 minute, and we'll see what we get on that. Man. You know what, guys? I'm kind of a science nerd and astronomer, so you gotta forgive my nuttiness here, okay? This is just a beautiful comet. We're probably never gonna see another comet like this in the near future. So this one is just beautiful. Just beautiful. And I know it looks just like a band of light, but that's, that's the tail of the comet. So this 1 minute shot now, we'll be able to see it. And if I recall, we did 3200 on that, right? Yeah, so we're not going to see it as noisy as the previous one. When we did this last one here, that one was 5,000. This one, 3,200. And this one, okay. Yeah, look at. Yeah, that's really pretty. Wow. I love it.
Surprised you're not catching any of the ion tail.
I know. And well, don't forget, it's also low to the horizon. I think we're actually viewing it through cirrus clouds, by the way. I had high cirrus, very, very thin cirrus clouds up there. And I think that's why it looks the way it does. So we're losing the ion tail, I think, in that high cloud, the high clouds. But you know what? I couldn't, in good conscience, not show all of you this. We have to see this. You gotta see
what it is.
Yeah.
Strike while the iron is hot.
Yeah, exactly. All right, so now I'm going up again. I'm gonna do another minute at 3,200 just to see a little bit more. In the last shot that we saw, not the last shot, but in several of the shots I showed you, there seems to be some brightening off to the side here. These are clouds we are definitely shooting through clouds. Gosh, can you imagine if we can get rid of the clouds? Wow.
You'd be rich beyond all meaning.
That's true. Yeah, that's true. But it's okay. It's okay. Yeah, so this is just beautiful, this turned out to be a wonderful evening. I had no idea that the comet was going to be visible yet. I was out there looking where it was going to be, and all of my astronomical portents that I consulted suggested that the comet would only be above the trees for minutes. And as it turned out, it was more like a half an hour to 45 minutes. Not bad. Look, it almost looks like someone's aiming a flashlight. Okay, but the thing is that the comet, one side of the dust tail will tend to be a little sharper, and this side tends to look like it has some frill, where material is sort of like on the inside edge of the curved orbit. And that might be what we're seeing here. But you got to keep in mind, we could be looking at it from underneath, from the side, from the top. We have to look at the 3D nature of it. It's in 3D. It is in 3D. Yeah. Wow. So that's really, really nice. Let me go back here now and see if we are able to head northward again by a little bit. Okay, and now we'll do another shot and see what it looks like, because I'd really like to see the extent of this comet. Let's check out the sky. Oh yeah, look at it. It's it was supposed to be a hazy kind of clear tonight, and that's kind of what we're getting here. Sort of looks pretty foggy almost, actually. I better check that, okay? So hang on there, let me go check, because if it's fog, we gotta shut down. So I'll be right back.
Okay. I'm going to play devil's advocate here a bit while Mark is gone. Not to knock the view, because it's great, but I do not think Comet NEOWISE is a great comet. It's a good comet, but it's not a great comet. Hale-Bopp and Hyakutake back in the 90s were great comets. They were obvious, and you could see them at their best naked eye. You can look at Comet NEOWISE, and if your sky conditions are good, you can see it naked eye, but it's you're not seeing very much of it naked eye. Binoculars or cameras are giving very good images. Mark's probably going to fire me now.
Why? What'd you say?
Because of what I just said.
Oh, what'd you say? How bad was it?
Pretty bad. Now, I said, in my opinion, as devil's advocate, I think NEOWISE is more of a good comet, not a great comet. It's visible in good conditions, but it doesn't show a lot naked eye.
Yep.
Whereas like Hale-Bopp did and Hyakutake did.
Well, Hale-Bopp was almost directly overhead.
And Lovejoy did.
Yeah.
It shows well with binoculars and it takes images wonderfully, but
yeah,
you're not seeing that much as a comet naked eye.
Yeah. Well, that's true. I mean, you're not going to get shot for that. That's true. I want to answer Martian Johansson. Thank you for coming, Martian. Thank you for hopefully you subscribed and joined SkyTour LiveStream. This is the tail of the comet, a little farther away from the comet. The cometary head is like down there, but we're doing that to follow the tail. Martian asked a question which is pretty interesting. She said, "Why would fog cause you to abort the operations?" Then asked the question of, "Is it because you might get fog on the optics and stuff?" And the answer is yes. And unfortunately, the fog particles are attached to little dust particles, and when they land on the optics, the fog will go away. The dust, the dust does not. So you end up with dust on the lenses, and then you got to clean it off. But unfortunately, what happens is when it settles onto the optics, is it kind of cements itself there because of the fact that it cements itself there because of the fact that it's actually been in a liquid, and so that liquid dries and it sort of acts like a little contact cement, and you have to clean the optics even more. I went out there and there is no appreciable fog yet. I would like to see if we can look at Jupiter and Saturn before we have to close up, because it is getting foggier and Jupiter and Saturn are visible. We have exhausted this comet, unfortunately, for tonight. But if it's clear tomorrow, it'll be back. We've got tons of photos we took of it tonight, including images like this one, really, really pretty. And then white light shots like this one, where you can actually see that beautiful sunlit color of the dust and then the cyanogen in the core of the comet. Really, really beautiful images like this one, where you can, well, that's a little blurry. You got a little problem there. Like this one, where you can see that too. And these comets are these interlopers that come into our solar system briefly, and then they're gone. And then they might come back in a few years, or they might come back in thousands of years. We just had a comet that came through that's not going to be seen for another 8,000 years, right? Or 6,000. 6,223, is that what it was?
I thought I heard 6,800 or something like that.
Okay. Well, who cares, right? So.
Not in our lifetime, at any rate.
No. All right, so here's what I'm going to do. I have to go and move the dome again so we can see Jupiter and Saturn, okay? I do want to say hello to Katie Q. Hello there. Nice to see you. Thanks for coming out. Marson, I hope that actually answered your question. If it didn't, please let me know, because I would certainly want you to get your answer. All right, and let's see. Yes, the droplets will have dust particles, and then they can. Yes, water evaporates, leaving the dust particle. That's correct. Yep, and any of the pollutants or anything in the water, exactly, Marson, it's going to act like a cement, and it's going to be on there, usually in the shape of the dust particle, and then you actually have to clean it with a cleaner. So I do want to avoid that. I do have an anti-dew system on the telescope, but that's not going to stop droplets from dropping on the lens. It's just going to evaporate the water faster. Okay. So I'm going to head out there and move the dome. All right, Daryl?
All right.
All right, I'll be right back, guys.
I can tell a story from back when I got my first Celestron. It was an 8-inch. One I learned the hard way. It had a corrector plate on the front like Mark's telescope does. Same kind of telescope, Schmidt Cassegrain. I had that thing out observing during the winter, not long after I got it. And I learned the hard way not to carry a cold telescope into a warm house. Uh, uh, I had carried my old Newtonian reflector in before, and it really didn't do much. I just turned the tube so it pointed down. It really didn't condense on the optics much. But I carried this telescope into a warm house, and it was like getting close to 0 Fahrenheit outside. And the scope instantly dewed up. It was completely covered with water, including the front corrector plate. And I like to pee my pants when that happened. That's one I learned the hard way. Basically, if you have a telescope out in cold like that, just leave it out overnight. You might turn it so it's facing down and cover it with a tarp, and just leave it until the next morning, and then recover the scope, and you won't have that problem. There you go, Tony. And Tony, you asked earlier, the weather conditions permitting, the comet should be visible from Pennsylvania.
I
mean,
believe so.
it's probably getting late tonight, but go out tomorrow night if you got clear skies, and you should be able to see it.
Yep. Okay, let's take the telescope and turn it all the way around. We definitely have dew out there, but I'm gonna try my best to just do a couple more objects. First things first, let me do this and turn on the telescope view so we can see where we are. Alright, and turn on the camera. Okay, and then we can head on over. So we've got Jupiter selected, and now we're moving the telescope. So you should see the telescope move down here, and there it goes. Spinning around. Okay.
Mark, does the telescope do anything for cable management? I mean, does it know, not to wrap the cables?
Yes. It
Cool.
does. Yeah. See, the sky's going to turn dark now, and we'll see stars zipping through. And it goes to one star, and if you look where the telescope is pointing, you'll see that it's heading to this star right here. What is that star? Well, we'll zoom in and see. Okay. It's right there at that star, which is being used as a guide star, basically. It's Albalda, and it uses that, and when it knows where that star is, which is right there, when it centers it, it's then going to head on over to Jupiter, which is over here. So you'll see this zip away here in just a couple seconds. There it goes. And now you'll see Jupiter pull into the view, and there it is. All right, so we have everything working as it should.
Very nice.
Yep.
No, Tony, I never did that again.
What mistake did you say you made?
I carried a telescope inside from near zero conditions outside. My first Celestron.
And it fogged up
first Schmidt
immediately.
Cassegrain, and that thing dewed up instantly. I mean, it looked like it had been out in a rainstorm.
Yep. Yeah, that's not a good thing. All right, let's drop this ISO here. Oh, no, another plane goes through our view. We had a plane pass right in front of the comet, and now we just had another plane pass in front of Jupiter. And these are all on record. We see them all. So let's drop this down to 50 ISO if I can. All right.
Callisto's on the left. In order on the right is Io, Ganymede, and Europa.
Thank you. Actually, I want to see if our system here knows that. Let's find out. Yeah, look at that.
Huh.
Callisto on the left, and we have Io, Ganymede, and Europa.
Oh, yeah.
Yeah, not bad.
Didn't know it would do that.
And the red spot should be visible right there, too. We should see the red spot. So let's go check it out, shall we? We're going to shorten the exposure because we don't need that much. I'm going to drop this down to 50. It's not that low in the sky. It is kind of low in the sky, but it's not that bad. And we are using the filter, so let's just do a 1/10 of a second shot and zoom in and see what we get. Oh, look at that. Well, we got something. There's a red spot. We actually see the red spot right there. It looks to me like because of the water vapor in the air, we're not actually able to catch all of the detail on the planet. It's really not good seeing, nor good transparency tonight. So, but we do see some things, yes?
Are you still on the filtered view?
I am. Should we go to white light? See what we get?
Might try that.
Sure.
Sometimes if you're looking through very high thin clouds, or if you want to call it fog, it can actually steady the view on planets.
That's right, but we're actually looking through water vapor tonight.
Yeah.
So that's not so hot. All right, I'm going to try this guy. And let me bring my... Okay, let's see here. All right. So let's do this. Let's actually bring up the ISO so we can see the moons, and then I'll focus on those. So you bring them up so you can just barely see them. And now what I'll do is I'll bring them down into the focus section and go that way. Okay, and now we focus. All right. Now we're on white light, so I'm going to drop the ISO way down so that I can get those images as small as possible before I focus. And then reduce the exposure a little bit, or increase, I mean, the exposure. So those moons come back. All right. Geez, Dale, you're going to town on that thing.
Sorry.
And then, that's all right. And let me now focus. So we come out. Hey there, Ice Marcel. How's it going? Thanks for joining us. And then we're going to go and focus again. Okay, that looks pretty good. As you can see, the sky is just pretty tormented by the water vapor, but we're going to give it a shot anyway. Daryl, thank you for letting us know what the moons were before, by the way. That was wonderful of you. Now I'm going to go and take another shot here, give it a little bit of a... give us a little bit... Let's just take a photo here to see the moons. Okay. Okay, so now those moons are right here. There they are. That's Callisto there. And you said this was Io, Ganymede, and Europa, correct?
Yes.
Yep. Yeah, we can see them. And you can see how unsteady they are. Ganymede's like the biggest moon in the solar system. It's the size of a planet. It's bigger than Titan by a little bit. So it's actually kind of interesting when it orbits another planet. Okay, it's called a moon, yet it's the size of a small planet itself. So, is it bigger than Mercury? I can't remember.
I believe it is, yes.
Yeah, so Ganymede is actually bigger than the planet Mercury, but because it orbits another planet, we call it a moon. See, and I believe Pluto is a planet. I'm sorry. That's me. I've told people time and again, and I won't bore you with the whole story again, but I sat with Pluto's finder, Clyde Tombaugh. I sat with him, and we talked. And the guy was really a very nice man. And Pluto was just, as far as he was concerned, it was a planet. But back then, there was still controversy, There was still controversial thought about whether Pluto was really a planet. I thought it was, and he thought it was. So, there, Oh, look at that shot. That's kind of cool. That's the white light shot. You can see the moons barely and a little bit of Jupiter there.
I think you can barely make out a little bit of the great red spot on the far
right there. Right there?
Maybe down just a hair.
Yeah,
right
maybe.
There.
Yeah, okay. Well, you know what? There are some nights where you can very easily see the great red spot. Tonight is one of those nights where it's really kind of tough. All right, but I wanted to show you guys Saturn and Jupiter tonight because I thought you would enjoy it. And then we'll view the comet in the next night if we can. Let's do a 13th of a second here and see what we get. No.
Yeah, you can see it there.
Yeah, right there.
About 4 o'clock.
That is the great red spot. Yeah, it looks beautiful. And we can actually see the moons as well. Because they're small point lights. All right, but obviously, for an astronomer, okay, I can tell you that this isn't very exciting for Jupiter, but it is exciting that we can see it and we can see some of the clouds. I would like to go and check out Saturn as well. And after we check out Saturn, then we will decide what to do with the night, because I don't think that there's much else that we're going to be able to see tonight because of the water vapor. We're going to have to close up. So I'm kind of violating my own rule here. Okay, Control 1. We head on over now to Saturn. Jupiter vanishes, and the telescope is now going to go to another star that it knows and that it can use. And that's the star I thought we were going to go to. And this particular star is it Dubin? I can't read that yet. Dabin? Let me get... or Dabila? I don't know. Let me get down there.
Capricorn, isn't it?
Yeah, I'm trying to see. Yeah, no wonder, because it was Dabi. And then Saturn you'll see flying in here in a minute. Maybe I gotta increase the time a little bit. Or the ISO. Yeah, that's kind of what has to happen here. All right.
Myanmar City, Orion's belt is not up right now. It's pretty much behind the sun.
Yeah. Oh, that's interesting. I guess I must have confused the telescope. Yeah, thought so. Okay, so we're going back to this, and then from there it's going to be able to jump down to Saturn. So that's the star Dubih, D-U-B-I-H. It's going to center it up. And once it centers it up, it knows where to go right from there to get to Saturn, which is right there. Oh, and look, we have Saturn's moon. I think that's Titan right there.
I think so.
Yeah, it's beautiful. This is a nice shot. Let's see what we can do here. Let's not do that high value. Let's just do a smaller one. Let's drop the ISO. Actually, you know what we'll do first? First things first. Let's go to Saturn here and check out which one that is. Okay, that's Titan. And then we should see Dione. And then we have Tethys and Mimas. That's just going to be really faint. So I'm thinking that we're probably going to be able to see Titan and maybe, well, maybe it's Rhea that we're seeing over here. Yeah, maybe it is. See Titan here and maybe Rhea.
Yeah.
All right. So let's do a 1 second shot on that just to check it out. Saturn won't be that easy to see, but we'll see more moons. That's for sure. There we go. Now we see all the moons. We have Titan, we have Rhea, we have Dione, and then is that Tethys maybe? We see all the moons anyway. I can't remember which was which. Okay, but we are looking at it in white light. All right, so now what we'll do is we're going to go, and because we know we're in the right light, I'm now going to drop it down so we can actually capture the rings. And to get the rings of Saturn, you got to drop it down to 125th of a second when you're at 6400. But we're going to drop this down to 50. You can see Saturn looks even, better at lower ISOs because you have less noise. Okay, now we're on auto. I don't want that. Okay, now here's 50. Now let's go and lengthen this exposure. And you watch here, you'll see Saturn coming into the view as we're getting a live kind of view of the product, So this looks pretty interesting. Let's try this. 1/5 of a second at ISO 50 of Saturn. And there we go. Let's see how it looks. Okay, there we are. Well, you know what? For the night, that's not all that bad.
It's not. You can make out Cassini's division even in the rings.
Yeah, right there. Cassini's division is a separator between these rings. You'll see a dark line that goes right through, and it looks like we can actually see it. Remember, it was a better night the other night. We couldn't even see it.
Yeah.
So that's interesting.
You can actually see a little bit of the crepe ring also. Where the lower part of what you see, the ring is passing in front of the planet, and where it's overlying the planet, you see a faintly darker band there. That's actually the so-called crepe ring of the rings.
That's right there. You see that little dark line.
Yeah.
That's beautiful. Really, really pretty. Well, let's just play with this for a moment and see what we can do. I don't know if the filter is going to help us. I think the white light views are probably what we want for this right now. But let's just go a little brighter and see if 1/3 of a second shows any more detail or less detail. We still see this line. We still see that, but it's kind of washed out a little.
Yeah.
Okay, so here's what I'll do. Let's go the other way. Let's see if we can shorten the exposure and say let's drop it down to... Whoops, went the wrong way. What's going on? Okay, here we go. All right, this will be 1/6 of a second now. Let's see if that gives us another Ooh. Well, now Cassini's division is really obvious. Look at that.
Huh.
You can see it. And the crepe ring is there. There's a lot of detail on Saturn if we actually have a really, really good night. So tonight, unfortunately isn't that night, but you know what? I'm still having fun. 1/10 of a second. Not bad. That's actually pretty sharp there on that inside edge. See that?
Yeah.
Wow. Well, that's it, man. It's beautiful. So we actually got to check out Saturn and so forth. We actually saw Comet NEOWISE tonight. I hope you guys really enjoyed that. On subsequent nights, we will indeed look for Comet NEOWISE again. And I'm going to work on seeing if I can do some wide-angle shots for you as well. But, live. In other words, piggyback mount. That'll take some doing, but I think I can do it.
That would be great.
I did it before, so we'll see what we can do. In any case, I hope you guys enjoyed that. And to revisit tonight's images, let's go back and check them out, shall we? We actually enjoyed Comet NEOWISE. This is an image of it we took right here. Okay. You can see the beautiful cyanogen coma here, several Earth diameters in size, and then the tail, which can be many millions of miles long. And this is with a filtered view. We took multiple shots of a filtered view at different times. This is longer times. If you want to know how long, we can just bring up all the data, which I don't know if you can actually read that. But the exposure time here was 25 seconds. And we were shooting this at an ISO of, and even I can't read this. I'm trying to read it. Yeah, I can't read it. I think we used somewhere around 5,000 for these, but I can figure that out. That's easy. This is just the metadata we're talking about. And then we actually took pictures in white light. That is the light that we see with our eyes. And the comet looked like this, which was really stunning. And of course the sky was a little bright still, but we actually saw this gorgeous view. This is a beautiful, beautiful shot of the comet in that regard. But hey, I think it's really cool. Hey there, Plexify, how are you? Yeah, the comet can be seen from Los Angeles, really well. Hey, Genghis, thanks, man. That's very nice. Thank you so much. Yeah, same to you, man. Same to you. Live long and prosper, brother. So the comet is also visible from Los Angeles, and it will be in the northwestern sky, kind of low to the horizon for much of its apparition, but it's going to be visible in binoculars easily, and the overall magnitude of the comet, the brightness, is going to start waning, getting smaller. It's going to go to 3 and 4, but for us, it won't matter. We're still going to be able to look at it this way because we got a good freaking setup, I tell you. So we're in good shape. So you guys, you hopefully had a good time tonight, and I think that the next time we look at the comet, it's going to be higher in the sky, and we'll get longer to look at it. So I want to thank you guys for attending tonight. And it was great to have you, Daryl. Thank you for coming along. I know it was short notice, but I didn't realize I could see the comet, and I knew fog was coming.
Oh, yeah. Well, and hey, if you get it again, give me a holler.
Oh, I'm going to definitely get it again. There's no doubt about it.
Alrighty.
And of course, now, if I go back to our remote view here for a moment, just want to give you something else. Hey, wow, thanks there, Rachel. I didn't even see her. Was that Rochelle? I didn't even see you there. I'm sorry. I would have said hi to you. This is our telescope view, and I'm going to show you the shutdown process, okay, so you can get an idea of what we do. So I'm now going to park the telescope, which parking the telescope puts it into a mode where it is ready to be shut off. So you'll watch the telescope. Thanks, Rock.
Hey, Rockstar.
So the telescope's now moving. You see it in the dome, moving. And I just got an alert on my phone. It vibrated saying the telescope is in motion. So now it's sitting there and it says it's ready to be shut off. Okay, so I can actually cut power out there, and I've got that all set up to do. I have a way of doing that. Now the observatory program allows me to control the entire telescope now, and this is actually the program I wrote. And what I do now is I just say over here I can enter my value, and you'll see the text show up. It's going to say that the telescope is shut off. Okay, and you saw that light go off. That means that the telescope is shut off. And then the last thing that I have to do is close the roof, which I can't from here. This is the Arizona program, which I'm doing right now by hitting number 6 actually, and sending. And right now the telescope has started the process of closing the roof for the Arizona scope, right? And then finally the last thing is this cover. You'll see this cover. This is closing the scope automatically, because the cover has to be closed. So I hit this next one, and now you'll watch this. Here it goes. And now, just like on the ISS, boom. Okay,
Wow.
telescope is now closed, and power is off. Telescope's closed. Roof is closed. If this was Arizona, so you see and it all has fail safes. I can't, for instance, I can't open the telescope while certain things are happening. I can't close the roof unless the telescope's parked. So that's what all this is over here. This stuff, gives me the option to do all these things. And I basically said, if this is happening, then you have this allowed, that kind of thing. So that's it. So you just watch the telescope shutdown process for tonight. So I hope you guys had a good time seeing that little bit of business. Really kind of cool. And now I can get rid of everything else. All right. So thank you guys for coming out. I really enjoyed having you with us. And as far as you guys contributing, you guys are amazing. You contributors, thank you so much. And Myanmar City, I'm sorry that you had only just joined us. We didn't show you much at the last moment, but you did. Here's the comment we shot earlier. Okay, more tomorrow if it's clear. All right, and until then, you guys have a good night, and I will talk to you on the flip flop. See you later.
Good night, everybody.